Hey, welcome back to your favorite pre-calculus class. We're going to look at polynomial and rational inequalities, section 4.4. We're going to solve them both graphically and algebraically, and then look at rational inequalities as well. So let's look at this first one visually here. We've got solve this function by graphing. So we're going to go ahead and put that into decimals. Here's a look at it. X plus 3 times x minus 1 quantity squared. Where's this thing greater than 0? Let me get my pen here. So where is this function greater than 0? Where's the functional value greater than 0? So we're looking, where's this thing positive, right? And then we got to name it in terms of the x values. So where is this function greater than 0? Okay, so you look at it and you're like, oh, all along here it's greater than 0. Not right here because it is 0, and then so on. So you got to name that in terms of the x. So we start out right here. What's that x value? -3. But can we include the -3? No, because it hits right on 0. So we say do not include, so parentheses instead of a bracket, up until, so this is all good, up until 1, and x value 1. Cannot include that. Again, we got to be strictly greater than 0. We got to be above that x-axis there. The functional values, the y values, have got to be greater than 0. And then we're going to keep going from 1, again not including the 1. We're going to keep going to infinity. So all these x values are included such that it's all above the x value, so to positive infinity. Or you can do it in terms of the set notation. You're less than 1, you're greater than -3, and then or such x such that, and then you're greater than 1. Okay, so that's your other way to do that. All right, let's look at this other one. If we're solving this now algebraically, what you want to do is get one side, this x to the fourth. Where is x to the fourth greater than x? So the first step is to get one side 0. So we're looking for, where is this function greater than 0? So number 1, get one side to 0. Okay, number 2, what you want to do is to find our critical points. Okay, these are your zeros or where you're undefined. Okay, so let's go ahead and factor this, find our zeros. So we got x times x cubed minus 1. It's a cubed right there. Where is this greater than 0? Again, we're just imagining this is equal to 0 because we're finding our zeros. And then go ahead and factor that x cubed minus 1. If you remember, a cubed minus b cubed factors into a minus b, a squared plus ab plus b squared. So I'm just following that pattern for that x cubed minus 1. So we've got x minus 1, x squared plus x plus 1. Alright, so where's our zeros? Well, here's our first factor. X could be 0. From the next one, x could be 1. And then where's this part 0? This x squared plus x plus 1. If you put that into the quadratic formula, it'll just spit out imaginary numbers. Okay, so let's plug it into the quadratic formula. Where is this piece equals 0? Plug it in. A is 1, B is 1, C is 1. So B squared minus 4 times A times C all over 2A. You see how underneath we're going to have a -3. You can't take a square root of -3, so you got nothing from that. So the only critical points that we have are 0 and 1. And so what you want to think about at this point is say, can I include 0 or 1? So I'm going to go right to here and I'm going to test my critical points right here in this inequality. Okay, does 0, so test critical points after you find the zeros. Critical points. So does 0 work? X equals 0. Does x equals 0 make it true? I'm plugging it into this. Well, 0 times 0 cubed minus 1 Is that greater than 0? Well, 0 times negative 1 is 0. Is 0 greater than 0? False. Okay, so I'm not going to include 0. Okay, this is just my testing interval here that I'm looking at. So I'm testing 0. I do the same thing for 1. Sorry, let me test 1, my other critical point. So I plug it into x times x cubed minus 1. Is that greater than 0? Well, 1 times 1 cubed minus 1. 1 times 0 is 0. Is 0 greater than 0? No. Okay, so you have to think about your critical points. Now, these critical points split this up into areas here. So testing intervals. So now we're going to test, after we decide if we're going to include or not include the critical points, and you just denote it with an open hole. If it would have been true, I would have denoted it with a solid hole. And this is just telling us our solution here. And you got to test to the left of your critical points. So test anything out here, like a negative 1. Test in between them, like 1/2 is between 0 and 1. And then just test something out to the right. Okay, and it's just going to tell us if this is true or not. Let me erase some of this here. So now we're testing with our values in between the intervals, okay? Alright, so let's test x equals negative 1, and we're testing it into x times x cubed minus 1. Is this greater than 0? Put the negative 1 in. Negative 1 cubed minus 1. So we got negative 1 times negative 1 cubed is negative 1. Negative 1 minus 1 is negative 2. So we got negative 1 times the negative 2, which is a 2. Is 2 greater than 0? Yes. So this is true. So I'm going to write in here true right there. That means that part from, okay, anything to the left of this 0, any x's out here, so coming from negative infinity up to 0, but not including 0, is going to be part of my solution. So it's saying this function x to the 4th minus x, that thing is positive, it's above the x-axis, right? Anywhere from negative infinity up to this 0. That's what this testing, that's why I'm testing it algebraically. Okay. And we throw in a half. So test half. So I got a half times a half cubed minus 1. Is this greater than 0? I got a half times an 8 minus 1. Is that greater than 0? I got a half times negative 7/8. Greater than 0. I got negative 7 over 16. So this negative 7 over 16, is that positive? No, that's a negative number, so false. Okay, similarly for the x equals 2, I'm going to test the 2. So I got 2 times 2 cubed minus 1. Is that greater than 0? Well, 2 times 7. Is that greater than 0? Sure, 14 is greater than 0. So this is true out here. So all this area then is part of it. From 1, I'm sorry, this is a critical number of 1. From 1 on, it'll be above the x-axis. So then we just write our solution. I'm out of room. Need a bigger area to write than this laptop. But that's what I got. Alright, so our solution set is from negative infinity up to 0, and then from 1 on. And that's again because it's true anywhere from negative infinity up to there, and it's true from this critical point 1 and on. Okay, so if you were looking at this in, Desmos, if you were graphing that, y equals x to the 4th minus x, and can you see how you're above the x-axis? I can't draw on this, unfortunately, it's out of the OneNote, but you're from negative infinity up to the 0 right here, you're above, and then from 1 on, you're also above on that. Alright, let's go back with this. Now, rational inequalities, whereas this one greater than or equal to 0, let's look at its graph. So notice it's greater than or equal to 0. This part, oops, come on. Come on. Alright, so from here, we're above the x-axis. Well, what x value do you start at? Well, right here at -2, but we're not going to hit this -2. We're not going to hit that -2, so we cannot include the -2. Oops, that's a -2. Do not include it because we got to be strictly above the x-axis. And then we hit 1. Oh, I'm sorry. This was greater than. Was this greater than or equal to? I think this was, yeah, greater than or equal to. I'm sorry. So greater than or equal to. So when we hit the 1 right here, it's equal to 0. You know, I hit 1, 0. So we can include that x value of 1 there because it hits the 0 there. And then again, where are we greater than or equal to 0 from there? What's that x value there? 2. Do not include that x value of 2. And we keep going on our x's. Okay, so we're saying where's the function? Where's the functional value? Where are my y values greater than or equal to 0? And then we name it in terms of our domain, names it in terms of our x values such that it makes that true. Now let's do our last one here, algebraically. Notice that it's less than or equal to 3, so you got to bring that over. So you got 3x squared plus 13x plus 9 over x plus 2. This thing is so touchy. It's 3 less than or equal to 0. We got to get a common denominator so we can combine these two. Let's put this over 1, get a common denominator, x plus 2 quantity squared. If I do it to the bottom, got to do it to the top here, x plus 2 squared. So we got 3x squared plus 13x plus 9 minus 3 times the quantity x plus 2 quantity squared. I'm going to go ahead and FOIL that. That's x squared plus 4x plus 4 if I expand x plus 2 times x plus 2. Now I've got this common denominator, x plus 2 quantity squared. Where's this thing less than or equal to 0? I'm going to distribute that. So I'm going to have 3x squared plus 13x plus 9 minus 3x squared minus 12x minus 12 all over, gosh dang this thing, all over x plus 2 quantity squared. Where's this thing less than or equal to 0? Well, 3x squared minus 3x squared gone. I got 13x minus 12x, so I got a 1x. I've got, let's see, a 9 minus 12. I got minus 3. This is over x plus 2 quantity squared. Where's this thing less than or equal to 0? So I got x plus 2, another x plus 2 here. Again, where am I less than or equal to 0? Well, now I'm going to take my critical points. So where are my zeros? Well, 3. If I have a 3 here, I got 3 minus 3 is 0, 0 over whatever on the bottom is 0. So I take my zeros. So here's my critical points are 3. And then my undefined points from the bottom is -2, and I get that from both of those right there. So 3 and -2 are my critical points. I gotta get some. Room here. Okay, so my critical points are 3 and -2. So that's what's going to go on my testing interval here. So I have to decide if I throw 3 in, and I'm going to go back to my factored form here. this is what I had, x, oh my goodness, x minus 3 over x plus 2 quantity squared. Where's this thing less than or equal to 0? If I throw 3 in, I have 3 minus 3 on the top, that's 0 over 3 plus 2, 5, 5 squared, 25, 0 over 25 is 0 less than or equal to 0, yes. So I'm going to include that 3. I throw negative 2 in, it's going to be undefined. So anytime I have an undefined critical point, you're not going to include that thing. And now we just got to test something out here, like a negative 3, test something between them. 0 is always good if they're between them. And test something out here, like a 4. And again, I'm just plugging it back into here to see if it works. So let's test the negative 3 first. I got negative 3 minus 3 over negative 3 plus 2 squared. Is this thing less than or equal to 0? Well, negative 6 over negative 1 squared is 1. So I got negative 6 over 1. Negative 6 is negative 6 less than or equal to 0. True. Yes, it is. So this is true. I'm going to include this as part of my solution set. I throw 0 in now. So I'm testing 0. 0 minus 3 over 0 plus 2 squared less than or equal to 0. Well, I got a negative on the top. I've got a positive on the bottom. So negative over positive is a negative. Is negative less than or equal to 0? Yes, it is. So we're true in here as well. I got negative 3 over 4. So negative 3/4 is definitely less than or equal to 0. Now we're going to test the 4. Throw the 4 in. I got 4 minus 3 over 4 plus 2 squared. So I've got a positive on the top. I got 1 over 6 squared. 36 is a positive number less than or equal to 0. False. So this is false out here. So now we can write our solution set on this thing. Should blow that up. So we go from negative infinity up to the negative 2. But notice we do not include the negative 2. We have this thing open. And then union, and we're going to take off from the negative 2. Do not include again. Cannot include the negative 2. It's all true up until 3. We can include the 3. See how it's all filled in? So we're going to have a bracket right there. Up to 3. Bracket that thing. There's our solution set. Thanks for watching. We'll see you guys in class.